Hey everyone, this is Michael from Bright Musical Circuits, and this is the new condenser microphone module. So this circle with the lines, that's the symbol I drew for the microphone capsule. So one half of it is connected straight to ground, and the other half is connected up here. You can kind of think of it, it works a little bit like a capacitor, only the dielectric is kind of the air between the two sides of the microphone capsule. And when you talk into it or put a sound source, the capsules are going to move around. And so that's going to affect whether it has too much or too little current in it. And as it expands, it's going to want to have more current to fill that up. And it's going to draw current into it. And then when it contracts, as the air moves, it's going to push current out of it, and it's going to go that way. So we have a bias voltage set up over here. That's what this part of the circuit's doing. So our 12 volts gets divided down by this 33K and 100K to be, I think that's about 5 volts. And then that gets filtered by these two capacitors here. And then this 33K here is our load resistor. So this is going to turn that current change into a voltage change. This is a voltage change here brought by the current change going on across this resistor. So we have a really tiny voltage change here that we then need to amplify. And it's going to be at around 5 volts, thanks to this DC bias here. So this 0.1 UF capacitor here is going to decouple the DC out of that, and this 100K is going to then recenter it around ground. And then that little signal is going to get sent to this amplifier, which has a 1 meg gain pot in its feedback loop, coupled with this 2.2K to ground. So this gives us a variable gain of about 0 to about 500. So that's a ton of gain, which you need for to amplify such a small signal like that. And then that gets decoupled again, just in case there was any DC bias from the op amp, which when you have that much gain, a little bit of bias becomes a lot of bias and DC offset. So we decouple it again, and then we amplify it a little bit more, but this is also here because of these 5 volt Zeners. So whenever this signal from the output of this op amp gets above 5 volts or below minus 5 volts, these Zeners are going to bypass this feedback resistor and just apply negative feedback immediately to bring the signal back down to plus minus 5 volts. And with that, we're able to keep it within the regular kind of synthesizer levels. And then this is our audio output from that, which goes to the 1K resistor to protect the op amp from getting shorted out or anything like that. This diode is passing the positive signal down to this 4.7 UF tantalum cap. I tried an electrolytic in here and it felt a little slow, and then tried the tantalum, and I liked it a little bit better. But it might not actually be that noticeable. If you've got a lot of electrolytic caps, feel free to toss one in. So that's charging this capacitor whenever a voltage goes positive, and then it's discharging through our release potentiometer and this 1K resistor to ground. So the amplitude goes up, you have a voltage that rises up, and then it will slowly fall down through this pot. And that gets buffered and sent to the envelope output jack, and that's our envelope extractor or envelope follower for the module. The output of that is sent straight into this comparator here, with the threshold set by this voltage divider with a 1 meg resistor on one end of it. So this is about 1.2 volts to 0 volts is going to be our threshold level here, if I'm doing that math right in my head. But that is setting the threshold of turning the gate off or on. So the lower you're setting that threshold, the more the gate is going to be turned on. And the higher the threshold, the harder it's going to be for that gate to get turned on. The gate is lighting up this LED here. The LED is connected to ground on one end and the output of the comparator on the other through this 10K current limiting resistor. And then the gate output, our comparator is putting out 12 volts, or plus 12 volts to minus 12 volts. And we want a gate that goes from 0 to 5 volts. So we send that through this diode first so that it's only going to pass 0 to 12 volts. And then we use this 2.7K and 2.2K voltage divider to then limit that voltage down to 0 to 5 volts instead of 0 to 12 volts. And with that, we get our gate output. And we're using the 2.7K and 2.2K because parallel, it's relatively close to 1K, which is the usual output impedance we want on these circuits. And then the basic simple filtering and connectors for the power supply. And that's how this module works as far as I understand it. And I'm the one who designed it. So thank you.